Hey guys, welcome. Yeah, so I'm re-recording my video on the determinants of 3x3s because A, I wasn't happy with the quality of that earlier recording, and B, the matrix we used in that earlier recording had a determinant of 45, which is not very convenient, whereas as you'll see, this matrix A here has a very convenient determinant. So we're going to be able to work with this matrix A again in future videos, say when we find the inverse of a 3x3 matrix. Okay, cool. Now, the method that we're going to use to calculate the determinant of this 3x3 is the same method I discussed in my video on the determinant of any n by n matrix. So you should watch that video. But what we did is expand along any row or any column. And so that's what we're going to do here. But yeah, in my earlier recording of this video, we had a matrix whose middle entry right here was 0. And what we said was that, like, if you have any 0 entries, you should expand along the row or column that contains that 0 entry or those 0 entries, because it will make your calculation very simple. But in this case, we don't have any 0 entries. And so the only convenience really we can create is an expanding along this third column so as to involve the smallest numbers. And I guess that makes our calculation a little bit easier. But yeah, before we expand along this column, we know that we need to figure out the value of -1 to the power of the sum of I and j for each entry. Really, we only need to do it for this third column, but let's do it for each entry really quickly. So for this entry, it will be -1 to the 1 plus 1. So that's -1 to the second, which is +1. So +1, which I'll just write as plus, meaning +1. And then for this -5 there, it's going to be negative. For this -2, it will be positive. You can do it more carefully if you'd like. And then for this 5 right there, it will be negative, and then positive, and then negative, and then positive, negative, positive, right? And again, for our purpose here, on this example, we just care about these 3 guys along the third column, right? Okay, cool. But otherwise, I think we're ready to start. So the determinant of the matrix A here, so det A, we'll start with the sign here, which is +1, which I'll simply write as plus. And then we multiply +1 by the entry right there itself, which is -2. So +1 times -2. And then we multiply both of these guys, +1 and -2, by the determinant of the 2x2 matrix that we get when we eliminate all the entries that are in the row and column that contains this entry here. So that's all to say, like, look at this, right? And eliminate the first row and the third column. And then you get the 2x2 matrix with entries 5, -6, -8, and 9. And that's whose determinant you want right here. So the determinant of the 2x2 matrix with entries 5, -6, -8, and 9. Okay, cool. And then we go, we move on to this guy. So it's technically like plus, and then, well, it's going to be plus and -1, so I could have just written a minus, but I wanted to be more careful and show you the whole process very deliberately. Yeah, plus a -1, and that -1 came from there again. And then this entry, right? So we multiply by -2. And that's that entry. And then now this time we eliminate the entries in the second row and the third column. And what we do, we are left with the 2x2 matrix whose entries are 4, -5, -8, and 9. So that's whose determinant we multiply by this time. So, and that matrix again is 4, -5, and then -8 and 9, right? Okay, cool. And we keep it moving, and we move to that guy, right? So we go plus, well, technically I could just write plus, and then this is kind of like unnecessary, but plus this, right? And then times the entry itself, and this time it's 3, and then of course times the determinant of the 2x2 matrix that we get when we this time eliminate this row and that column, and the 2x2 we get has entries 4, -5, 5, and -6. So 4, -5, 5, and -6. Yep. Okay. And let me slide that a little to the left. Right. Okay. Cool. And there we are, and we simplify, and we should find the determinant of A, and should find it a pleasant surprise. So negative 2, as I said, it's convenient. Negative 2, and the determinant of this 2 by 2 is 5 times 9, which is 45, minus negative 8 times negative 6, and that's positive 48. So we have 45 minus positive 48. And then this minus minus is going to turn into plus 2 times. And then the determinant of this 2 by 2 is, again, 4 times 9 is, I don't know why I said again. It's 36. 36 minus, and then it's negative 8 times negative 5 this time, so that's positive 40. So it's minus, but it's positive 40, the product of negative 8 and negative 5. So 36 minus 40, and then we go plus, and then it's going to be 3 times, the determinant of this matrix is, what is that? 4 times negative 6 is negative 24. So negative 24, and then minus, and then it's 5 times negative 5, so minus negative 25. Okay, cool. So some negatives to keep track of, but not hard. So this is negative 2 times, and this is clearly 45 minus 48 is clearly negative 3. So negative 2 times negative 3 plus 2 times 36 minus 40 is negative 4. And then plus 3 times, we have negative 24 plus 25. That's positive 1. Okay. So this is going to be 6 minus 8 plus 3, also known as 9 minus 8, which is 1. And now you see why I thought that this matrix had a convenient determinant. Okay, cool. As I said, we're going to work with this 3 by 3 when we find the inverse of a 3 by 3 matrix. So the same matrix A here. But yeah, keep watching, and I hope this helped.